Return again. Your student professor, Dr. Dolphy Gilpin, with some chemistry, and we are on molarity, concentration, molecular weights, and we're using the formula molarity of base times volume of base equal molarity of acid times volume of acid. Let's return and do some problems. Okay, I've come up with a blocking pen here. And so we're using the formula now, M equals molarity and the formula is B equals base, V equals volume, and A equals acid. So molarity of base times volume of base equals molarity of acid multiplied by volume of acid. And a typical equation would be like an acid is HCl plus NaOH, which would give yields now acid plus base salt plus water, NaCl plus H2O. And that is already balanced. And suppose we're given that the molarity of the base, which is here, is say 2 for simplicity. And that the volume, let's do that the MB equals 2 and volume of base is equal to say 2, I put everything in liters here, and that M acid is equal to the number 3 and its unit. So use the formula we could calculate now. We are given the molarity of the base, and we're given also the volume of the base, and we're also given the molarity of the acid. So the unknown here would be the volume of the base, the volume of the acid. So we say now that the volume of the acid would be equals to the molarity of the base times the volume of the base over the molarity of the acid. And we're given some numbers here. We just plug them in. MB, I just give those numbers arbitrarily from my mind. VB was 2 liters, so it's already in the right thing. And MA, 3. So that the volume would turn out to be in liters, would be 4.3 liters for the volume of the acid. Suppose now we are given that the volume from this formula here, VB equals 0.2 liters and VA equals 0.3 liters and MA equals unitary, making things like simple. Then what we have here is that MB is unknown, so molarity of the base, sodium hydroxide, will be equal now to MAVA over VB. And that would be equal now to MA1 multiplied now by 0.3 over VB 0.2 that's equal to 0.3 over 0.2, that's equal to 3 over 2, that's equal to 1.5. So the molarity of the base will be equal to 1.5. To calculate the units for molarity there. I suppose if we use another equation here, say another acid would be like sulfuric acid, H2SO4, acid plus base, and we use, say, magnesium hydroxide here. And that would give us now salt, magnesium sulfate, plus water. And let's balance this thing here before we do anything. SO4, SO4. We have 4 hydrogen. So we have 4 hydrogen. We have 2 oxygen, 6 oxygen. So we have 4 oxygen, 6 oxygen, 1 magnesium, and 4 hydrogen. So that looks balanced there. And we usually have a little way to do things here with a crisscross thing. We put like the mass and the molecular weight at the bottom here. molarity of the base. This would be the base. So we have now MAVA is equal to MBVB. Or if you crisscross, we have MA upon MB is equal to VB upon VA. Or if we invert, we could have MB upon MA equals VA upon VB. Which if we crisscross here again, we go back to the original. So that this would be the base, this would be the acid, and this would be the base. There was some trick about using the valency, and 2 come into the formula here, depending upon the valency and the volume of the reactants and the product. Let's just drop in some numbers here using MA, given MA molarity of acid 0.5, and that the volume of the acid and that the volume of the base then we could calculate now that molarity of the base equal to MAVA over VB. And we have some numbers here, we just plug them in. Let's put that in liters to make things simple here. Not going to complicate anything here. This 0.25 liters, so everything must be in liters and gram. Alright, so 0.5 over 0.25 liters. This is 0.7 liters. 5, 5, 2 is 10. That's the same as, all right, let's do it this way. 5 multiplied by 25 over, you multiply this by 5 and this by 100, 10, 100, so that's 1,000. And that would be 0.7. So this would be 125 over 1,000 multiplied by 10 upon 7. So we invert. This is a 7 upon 10, so we invert. One, 2, 5, 0 over 100 multiplied by 7 equals to 12.5 over 7. So that will be equal to 717 7749 7856 7535 and so on. 1.785 would be MB there. Watch out for a little trick here when you come out with the form. When this formula here is just a one-to-one volume here, there's a trick with if this coming with 2, then we have to divide by 2 somewhere along here. So you have to watch out for a little trick on the formula MAVA. Sometimes it's MAVB multiplied by MAVA over 2. But let's just take a break from here and so remember we could also calculate the density. Sometimes it's required to calculate the density, sometimes the concentration, and sometimes the amount of molecules by Avogadro's number. This is 6.02 multiplied by 10 to the molecule.